We're on page 2 now, and this fits that pattern we just talked about. See, it's the same two things, 3x and a 2, 3x and a 2. One of them subtract and the other's add. So the answer should be two terms, and it should be the square of 3x take away the square of the number 2. I'll multiply it out the long way again. 3x times 3x, 9x squared. 3x times 2 is plus 6x. Then minus 2 times 3x, there's the opposite popping out. Minus 2 times plus 2 minus 4. These kill each other off, and we're left with the square of 3x take away the square of the number 2. Oh, let's go down again. 6x minus 1, 6x plus 1. I'll multiply this out again the long way. 6x times 6x, that's 36x squared, plus 6x minus 6x, and finally minus 1. And the middle term is, there is no middle term, it's 0. If you really want to insist on writing something, you could put plus 0 in the middle, but why bother? So there it is, the square of 6x take away the square of 1. So let's not beat around the bush anymore. Does this fit the pattern? Is that a plus b, a minus b? Yes. So instead of doing the 1, 2, 3, 4 multiplications, I'll just square the first thing, square the second thing, and put a subtract sign in the middle. And if you want to multiply that out the long way, be my guest, but this is going to be the answer. Now this is different. We'll come back to that in a little while. Let's go back up to the top of the paper. Does this fit the pattern? A plus b, a minus b? Yes. So what's the square of 3x? 3x times 3x is 9x squared. 4y times itself would be 16y squared. Put a minus in the middle. See what bunch of time we save knowing this? Does this fit the pattern? Same two things in both sets of parentheses with one minus and one plus. So no need to work too hard. There's the square of 2m, the square of 5p, and put the minus in the middle. And one more like this. Square that, you get 30. Oh, well, I should draw your attention to the fact that you do have the pattern. You got an a minus b, a plus b pattern. One subtract, the others add. Everything else is perfect match. 36m squared, 49p squared, put minus in the middle. The end of that. Okay, now let's move down here. I'll tell you what this does not mean. This does not mean just do x squared plus 3 squared. No, no, no. X plus 3 squared, remember the definition of this exponent is that it says you write this out as many times as the exponent says, and then you multiply your stuff together. So I got to write x plus 3, x plus 3. Now we're back to what the first few we did. They're not opposite signs. Yes, a match otherwise, but they're not opposite signs. So as I multiply this out, I should get 3 plus 3. I should get 6x in the middle. Let's see, x times x, x squared, x times 3, 3x, and then 3 times x, 3x a second time. We get the same thing twice because of the sameness of these parentheses. We do get something in the middle that's kind of predictable. You wind up with the same thing twice, so you could say you get double whatever this times this is, whatever the number and the letter multiplied together are, or whatever the first and last things are. Very first and very last. So what happens here? Again, let me struggle through this the long way. There's a 2 out there. See, if there was a 3 out there, we'd have to write 3 sets of parentheses. If there was a 5, I'd have to write 5 sets of parentheses and very carefully multiply everything up. Don't worry, we're not going to do anything like that in Math 1050. So, multiplying this out, you see we're going to get minus 3 and minus 3. We're going to get minus 6x in the middle. Double that. Minus 3x a second time, and then plus 9. So it's x squared minus 6x plus 9. So how were these two different from each other? And how were they the same? They both had an x and a 3, but this was x plus 3 squared, so we got plus 6x in the middle. This one was x minus 3, we got minus 6x in the middle. But in both cases, we got the square of the first thing in the front and the square of the second thing in the back. Minus 3 squared is still a plus 9, right? And the middle term was the a, you could say the a times the b doubled. See, 3 times x, double it, you get 6x. Minus 3 times x, double it, you get minus 6x. So let me stop the tape here, and we'll do a separate video for page 3.